In question number 4, that same exercise 7.1, it says L and M are two parallel lines intersected by a pair of parallel lines P and Q. That means we are given this line being parallel to this line, and the other pair, that is this line line P and then line Q, are also parallel. And they are acting as a transversal of each other. And what we have to show finally is these two triangles as congruent, like the triangle one is this. So the one triangle, and we have to prove this triangle being congruent to the other triangle, as you can see, is this one. These two triangle is what we have to prove congruent. Now, one thing is very clear that when two lines are intersected by a transversal, then the pair of alternate interior angles are equal. So let's identify which are alternate interior angles. Line this is parallel to this. Considering this to be transversal, can we say that this angle is equal to this angle? And that's by alternate interior angles. Now, when we consider the other two lines being parallel, like when I consider this line, this being parallel to this, right? Now, when we consider these two lines being parallel, again, here I'm taking this being the transversal, this one, right? AC being the transversal, right? So what we realize, there's another pair of alternate interior angles. That means this one is equal to this, right? So we got two pairs of angles as equal. So let me show you once again. We have this angle is equal to this angle, and this angle is equal to this angle. Now we have to prove these two triangle congruent, as it is very clear from the figure that we have two of these angles are equal and there is a common side, AC being the common side. AC is the common side. So we can prove these two triangle congruent. So I'm proving it here. We'll consider the two triangles as it is clear. This is triangle AD, or let's write in the order given in the question. This triangle ABC and the other triangle, that is triangle CDA. I'm writing this angle as 1 and this being 2. Say this be 3 and this be 4. That's what you will do in the examination. You will redraw this figure in your answer sheet and name these angles as 1, 2, 3, 4. So we'll write angle 1 is equal to angle 2 and angle 3 is equal to angle 4. The reason is same here. That is, these are alternate interior angles. So once the triangles become, these two angles become equal, now we'll write AC is equal to CA, that is a common side. This is common. And therefore we can write this triangle as ABC is congruent to triangle CDA. And this is congruent by, that's by ASA, right? I think this is what we need to prove. There is no further supplementary part of this question.